Okay, so example number 3 of graphing exponential functions. This one we're going to tackle a little bit differently because our equation is going to be y is equal to 2 times 1/2 to the power of x minus 5 plus 5. And if we notice, our base is 1/2, and that's a little bit of an ugly number to work with. So we're going to convert that. And I can rewrite that as 1/2 as 2 to the power of negative 1. So again, I can think of 1/2 as 2 to the power of negative 1. Those two things are equivalent. So if I decide to use 2 as my base, which is a much easier number to use later on down the road, I'm going to just convert my equation down below. So it's now going to be y is equal to, the a value of 2 is going to remain the same, but now it's going to be 2 to the power of, now because it's a negative 1, times x minus 5 plus 5. And we're going to keep the negative 1 on the outside, and we will see why in a second when it comes to our transformations. So first, let's do those transformations. We have an a value of 2, so that means we're going to have a vertical stretch of 2. We have plus 5 at the end, so we have a vertical shift up 5, so up 5. And then we have a horizontal shift to the right 5, so to the right 5. Now, we also have this negative 1 on the outside here, which means we're going to have a reflection over the y-axis. And that's because our negative sign is in our exponent here. So first, let's knock out my asymptote. I do have a vertical shift of 5 going up 5, so my asymptote will be at y is equal to 5. Now for my other transformations, I'm going to write them out completely now. So first, my vertical shift. Oh, not my vertical shift. My vertical stretch of 2. I have my reflection over my y-axis. And then I'm going to the right 2. And then up 5. I'm actually not going to the right 2. I'm going to the right 5. All right. Now that we have all of that information out of the way, let's go ahead and make our tables. Before that, let's make sure we apply our transformations properly. So my reflection over my y-axis and my shift to the right 5 will affect my x. So it's going to become negative, and it will be adding 5. And then my vertical stretch of 2 and going up 5 will affect my y. So times 2 and plus 5. So let's go ahead and do our values here. So I'm going to use the equation below. So I have a base of 2, so that's going to be 2 to the power of x. So using negative 1, 0, 1, and 2, like we have done before, that will give me y of 1/2, 1, 2, and 4. So let's go ahead and transfer these values over here. 0, 1, and then 0, 1, and 2, and then 1/2, 1, 2, and 4. So if I turn this negative 1 and multiply it by a negative and add 5, that will be positive 1 plus 5, which is 6. Negative 0 plus 5 is going to be 5. Negative times 1 would be negative 1 plus 5, which is 4. And then negative 2 plus 5, which gives me 3. On my y values, I'll multiply by 2 first, and then I'll add 5. So 1/2 times 2 is 1, plus 5 is 6. 1 times 2 is 2, plus 5 is 7. 2 times 2 is 4, plus 5, which give me 9. And then 4 times 4 is, or not 4 times 4, 4 times 2 is 8 plus 5 is 13. So now let's go and plot our values here. So 6, 1, 2, 3, 4, 5, 6, up 6, 1, 2, 3, 4, 5, 6, 5, 7, 4, 9, and 3, 13 will be somewhere up here. Also, what I forgot to graph, which I should have earlier, is my horizontal asymptote at y equals 5. So let's go ahead and do that now. And now let's go ahead and connect our dots. So it will approach like this. Again, we'll never touch our asymptote. So the last thing we have to wrap up and do is our domain in our range. So my domain is going to be all real numbers. Again, my domain for every exponential will be all real numbers, and then my range will be dependent on my asymptote. So again, we have an asymptote of y equals 5, so 5 to infinity. And that is our last example here of graphing exponential functions.